All right, in this video, we're going to introduce the trigonometric functions. Before we consider them as functions, let's just see how they're modeled on a right triangle. So here we have a right triangle and one angle inside the triangle, theta. And we'll label the side opposing theta as the opposite. We'll also label the side which is adjacent to the angle and the hypotenuse. And the trig functions are defined from there. In particular, we start with sine and cosine. So the sine is defined as the ratio of the opposite over the hypotenuse. And the cosine is the ratio of the adjacent to the hypotenuse. Now, all the other four trig functions are defined in terms of sines and cosines. But I also like to remember what tangent of theta is. In terms of the side. So initially, tangent is sine over cosine. But if we put what sine and cosine are in terms of opposite and hypotenuse and adjacent, then we get this fraction over a fraction. But when simplified, we get the tangent is opposite over adjacent. I remember those three in that manner. But then the other three, I just remember that they are reciprocals of these. So, for example, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So, real quick example, before we leave the right triangle, suppose we have a triangle like this, and we know one angle, and we know one side, say the hypotenuse. And if we have an angle where we know what the cosine is, then we can, or the sine, we can fill in the other sides. So 30 degrees is the same as pi over 6, and it's well known that the cosine of that angle is the square root of 3 over 2. That's one you are going to have to know. Well, that means we know then that x over 5 is square root of 3 over 2, right? Because that's what cosine is. It's adjacent over hypotenuse. And then we could solve for our x. It's 5 root 3 over 2. All right, that's the right triangle model for sine and cosine, but for us, we're going to use probably more the next model, which is the unit circle model. So on the left, we see the circle radius 1 centered at the origin. That's the unit circle. And we take an angle. The ray which defines the angle where it intersects the unit circle, its x-coordinate is the cosine, and its y-coordinate is the sine. That's another way to define the sine and cosine as x and y coordinates of points on the unit circle. So, for example, let's suppose we're at 0, the angle 0 degrees, which is 0 radians, and we're right at this point here. That would be the point 1, 0. In particular, the y-coordinate is 0. So that tells us that sine of 0 is 0. Now, if we look down on the bottom right here, there's a graph. This is going to turn out to be the graph of the sine function. But right now, we only know one point. We know 0, 0 is on the graph, right? Because when we plug 0 in, thinking as a function now, 0 comes out. All right, well, let's suppose we have a point moving around here, or the angle's increasing, and it goes all the way up to pi over 2, 90 degrees, but pi over 2 in radians. When you're sitting there, your y-coordinate is 1. So that tells us that sine of pi over 2 is 1. And if you look at the corresponding point on the graph, pi over 2 would be about here on the x-axis. So when you plug pi over 2 into sine, you get 1 out. Let's continue. Suppose our angle increases all the way to pi, which is 180 degrees, but pi radians. When you're sitting there, your y-coordinate is back to 0. So that tells us sine of pi is 0. There's the corresponding point on the graph. And continuing, suppose our angle increases to 3 pi over 2. You see the y-coordinate is now down to -1. There's the corresponding point on the graph. And finally, if we go all the way, we come full circle here, pun intended. We've gone 2 pi radians. We're back to the y-coordinate being 0. So sine of 2 pi is 0. There's the corresponding point on the graph. By the way, counterclockwise is by convention, angle is increasing, so positive angles. If you go clockwise, that's fine. It's just the convention is your angle is decreasing. So if we go from here down in this direction here, that would be negative pi/2. So that would seem that the sine of minus pi/2 would be -1, right? That's the y-coordinate when we go down that way. So there's the corresponding point on the graph. All right, and if you continue, you can continue indefinitely. This graph to the right and left would infinitely repeat. Okay. Now, just as you are going around and around the circle. So let's just end with mentioning the cosine. Now, I'm just going to draw a couple points for the cosine. Let's suppose we're back here at 0. And now the x-coordinate I want you to trace. So the x-coordinate is now 1. So that would tell me that 0, 1 is on the cosine. And as you go counterclockwise, when you get up to pi/2 with your angle, now the cosine is at 0. So that would tell me this point here would be on the graph. And as you go from pi/2 to pi, the x-coordinate is going from 0 down to -1, right? So that means this point here would be on the graph, pi -1. And what's going to turn out is the cosine is shaped just like the sine, but it's just shifted by 90 degrees or pi/2. So if you track the x-coordinates, you're going to get something like this. Okay, so that is how the sine and cosine you should think of as functions of. Now notice I have function of x, but look, x is just a number, as is theta. Okay, so you can think about it going around and around the unit circle, but if you trace out the x or y coordinates, depending on what you're looking at, sine or cosine, you get graphs like these.